Good day, everyone. I am Dr. K. I welcome you back to my channel. So today we'll be discussing radioactivity. So this lecture will be one of the series of lectures I will be releasing on radioactivity. So this is the introductory one, which I would like you to follow. So, but in this video, my emphasis will be on radioactive decay. So that's what my emphasis will be on. And when you talk of radioactive decay, you know, um, when nucleus of a substance break down, nucleus of an element breaks down or disintegrates. So that's radioactive decay. So in order for it to become more stable, so that's it. Now during radioactive decay, there are some questions that can come up on it that you'll be asked to. That was the fraction left, what fraction has decayed, are you getting it? It can be very confusing. So you need to be able to distinguish between fraction left and fraction that has decayed. So that will be my emphasis in this video. So, but before we continue, I will define some terms. Are you getting it? So in order to be able to get this lecture right. Now, when you're talking of radioactivity as senior, so radioactivity is simply spontaneous emission of radiation. Are you getting by an element? So it's just the spontaneous emission of radiation, the process by which an element emits radiation. Are you getting it? So you cannot talk of radioactivity without using the word spontaneous. Are you getting? When you say something is spontaneous, it means it happens without anything really causing it. So that's the meaning of spontaneous. So that's it. Just emission of radiation. So and the radiation could be from we have alpha radiation, it could be beta, it could be gamma. So that's that. So now let me talk of radioactive decay. Are you getting it? Radioactive decay. So when you're talking of radioactive decay, you're talking of the spontaneous breakdown of the nucleus of a substance. Yeah, as a result of it emitting radiation in order for it to become more stable. Are you getting it? Now, an element that is already stable cannot emit radiation. I cannot, doesn't need to decay. Are you getting it? Doesn't need to emit radiation. But in order for them to be stable, so they have to emit radiation. So that's what radioactive decay is talking about it breaking down. Are you getting it? Until it becomes stable. So for example now, let's say carbon, for example. So for it to maintain stability, it has to keep breaking down in series of steps. So that's that. So let me define half-life also, because we need it to understand this concept I'm teaching in this video. So when you're talking of half-life, you're talking of the time taken for half the sample of a given element to break down, to decay. Are you getting time taken for half the sample of that element to decay? That's what you call half-life. Are you getting it? Half-life. That's the time taken for half the sample to decay. So for some elements, it could come in years, some it could come in weeks, some it could come in days. Are you getting it? So it depends. So now having said, okay, let me illustrate this. For example, now when you talk of let's say you were given a 5 gram of carbon. Are you getting it? 5 grams of carbon. So they now said okay, 5 grams of carbon. Now, what's the half-life of that carbon? Time taken for half the total number of that 5 gram of carbon to break down. For example, now half of 5 gram of carbon is 2.5. Are you getting it? Now, time taken for 2.5 gram of it to break down is what we refer to as half-life. Are you getting it? So that's what you refer to as time taking for half the total number of it to break down. So that's the half-life of that substance. So for example, now if it takes 3 years for half of the 5 gram of carbon given to break down, that will be the half-life of that substance. So that's it. Now, before I having said all those things, I want you to put the definitions in mind. Then I can go ahead and do exactly what I came to do here. So now you were given, let's use this example. They now said an element undergoes radioactive decay. Are you getting it? An element undergoes radioactive decay. So what fraction of it has decayed after 3 half-lives? What fraction of it has decayed after 3 half-lives? So I will illustrate that. An element undergoes radioactive decay. That's the question. So what fraction of it has decayed after 3 half-life? So now this is how to approach a question like this. So you were not given any number that is the particular amount of that substance. Are you getting it? Now the first thing you do is to take it to be 1. Okay, this is the original. So take it to be, so take the element to be 1 gram. 1, okay, 1, okay, 1, okay, take it as 1. So as a whole number. Are you getting it? So they now said what fraction of it has disintegrated after 3 half-lives. Now, so after 3 half-lives. Now, how do you go about something like this? They said an element, that what fraction of an element has disintegrated after 3 half-life. When you're talking of decay, you're also talking of disintegration. Now, how do you do this? So this is the approach you give it. This is the approach you give it. Now, first half-life. First half-life. So half of it will decay. Don't forget that half-life is the time taken for half of the total number of substance to decay. So that will be 1/2 times 1 will decay. Are you getting 1/2 times 1 of it will decay? So that will give us, because so we have 1/2. 1/2 times 1 is the same thing as 1/2. Are you getting it? Now they said after 3 half-lives. Now second half-life. So now second half-life, do you know what will happen at the second half-life? Is half of this one. Okay, don't let me. So it's half of this one that has decayed, half of this one. This is the amount left. Are you getting it? This is the one that will decay. So okay, let me write this properly. Second half-life. So that will be 1/2 times 1/2. That's half of this one has decayed. Are you getting it? So it will give us 1/4. Okay, 1/4. This one has left. Now, third half-life again. Third half-life. Then what do we have? 1/2 times 1/2 times 1/2 will be left. That will be, so it will give you a total of 1/8. Are you getting it? So now the question says, what fraction has decayed after 3 half-life? Now what we have just found is this is the fraction left, fraction that remains. Are you getting it? This is not the fraction that has decayed. Are you getting it? So when you are calculating, look at the first half-life. So this is the original one. Half of one has decayed. Are you getting it? Half of one, that will be 1/2. So second half-life, it is the half of what is left in after the first half-life that will decay, and that will break down again. Are you getting it? And you have 1/4. Then third half-life again, it is half of the what you have left in the previous one. Okay, I should have used it as, I could have easily used it as 1/4. Are you getting it? Times 1/2. So it will be 1/8. Now, after 3 half-lives, 1/8 is left. Now, how do I calculate the fraction that has disintegrated? That means I will have to subtract the fraction left from the original given. Are you getting it? From the original fraction given, So the whole number. So that will be, so fraction that is disintegrated will now be 1 minus 1/8. So if I I can, this my 1, I can turn it to 8/8. It's the same thing as 1. So it will now be 8/8 minus 1/8. So what I will have is 7/8. Are you getting it? So this is telling us that after 3 half-lives, 7/8 of that substance has decayed. So this will be all on this. So in another video, I will be releasing more areas problems can come on radioactivity. Thank you.